Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever found yourself totally lost in a video game or immersed in a virtual world, forgetting everything else around you? Well, this new research dives deep into how we learn and interact in these super cool immersive media environments, especially when a virtual teacher or guide is involved. Imagine stepping into a virtual classroom or a simulated workplace where a friendly virtual character guides you. That is what we're talking about. Pedagogical agents in extended reality, or XR environments. Think virtual reality headsets, augmented reality glasses places where computers can make you feel like you are really there. Scientists are super excited about this because it opens up totally new ways to learn. But there is so much we don't know yet. This paper is a big review, pulling together what we do know and figuring out the important pieces of this puzzle. They've come up with a framework, like a map, to understand how these virtual teachers and the immersive worlds work together to help us learn. So at the heart of it all is this virtual character, the pedagogical agent. They're not just characters in a game, they're designed to teach you something. And they're in these immersive worlds, we call that extended reality, or XR, which includes VR and AR. Think about learning history by visiting a virtual ancient Rome, or practicing a surgery in a super realistic VR simulation with a virtual assistant guiding you, or even learning about climate change by talking to virtual locals in an affected region. These agents can be like tutors giving help and asking questions, or like playing partners, letting you practice real-life situations. Now, when we talk about virtual characters, we often see avatars that represent real people and then agents that are controlled by computers. This paper is mostly focused on these computer-controlled agents, your virtual teachers. It is a subtle but important difference because how we react to them might be different. So, what makes these XR learning environments special? First, there is high immersion. This means the technology really pulls you in, making you feel like you are physically there. Then there is multimodal body-based interactivity. This means you can interact with the virtual world using your whole body, your movements, your voice, even your gaze, and you get information back through different senses. Not just sight. Think about putting on a VR headset. Suddenly, the real world disappears, and you are somewhere else. Your head movements control what you see. Your hands might control a virtual tool. It's this intense feeling of being there that immersion creates. And interactivity means you can do things, and the world reacts. And when you are in these worlds, you often have a virtual self, an avatar. The more realistic this avatar looks and moves, the more likely you are to feel like it is really you. This realism isn't just about how good it looks, but also how well it moves and acts like a real person. The same goes for the virtual teacher, the pedagogical agent. If they look and act very much like a real person, it can make the interaction feel much more natural and engaging. But just having cool technology isn't enough. The paper stresses the importance of instructional design principles. This is like the recipe that tells developers how to use the technology in a way that actually helps people learn. Not just distracts them, these principles bridge the gap between the tech and how our brains actually learn. When you are in an XR environment, a few things happen with your sense of self. There is physical presence, that feeling of actually being in the virtual place. Then there is self-presence, which is how you see yourself in that virtual space, often through your avatar. And then there is embodiment, this feeling of having a virtual body. It's like you inhabit the avatar. This can be a really powerful experience, making virtual actions feel more real. However, there is a big potential downside: cyber sickness. That is the motion sickness you can get from VR or AR with symptoms like nausea and dizziness. It is a major hurdle for widespread use. Now, let's talk about how you experience the virtual teacher. A key concept here is social presence. This is that feeling of being with another intentional social being. Even though you know it is a computer, you might feel like you are actually interacting with another person. This can lead to the development of a human agent space, which is basically your personal connection with that virtual agent. Things like trust and a sense of togetherness. And then there is agent awareness, which is your understanding of the agent's characteristics, like their personality or what they're trying to do. All these factors influence how you socially interact with the agent. One of the most interesting findings is that people tend to treat these virtual agents much like they would a real person. This is based on the idea that computers are social actors. We unconsciously apply social rules to them. So you might say please and thank you to a virtual teacher. Your interaction can also be looked at in terms of its direction intensity, and persistence? Is it focused on the learning task or more on building a relationship? How strong and how long does it last? The task-related direction of social interaction is when you and the agent work together on the learning material, like discussing a problem. The sense of presence in VR can really boost this, making you feel more invested in the task. Social relational direction of social interaction is more about building that connection, like sharing personal information. This is where that human-agent space really comes into play. And then there is the Proteus effect. This is a cool phenomenon where your virtual self-representation influences your behavior. If your avatar is tall and confident, you might act more confident, and this can be amplified in immersive environments. Beyond the social interactions, the paper looks at immediate learning factors. These are things happening right then and there that affect how well you learn. Social emotional reactions are a big part of this. Immersive environments can make you feel emotions more strongly, both positive and negative. This can be a double-edged sword, great for engagement, but potentially distracting if the emotions are too intense or negative. Motivation is another key factor. Immersive tech can boost motivation, partly because it is exciting and new, but also because the virtual agents can build a connection that makes learning more appealing. Self-efficacy, which is your belief in your own ability to succeed, can also be boosted. Successful experiences in these realistic simulations can build that confidence. But then there is cognitive load. This is the mental effort needed to process information. Immersive environments can actually increase cognitive load because there is so much to take in and process. This is especially true in VR, where the whole world is virtual. Too much extraneous cognitive load, that is the load from distractions or poor presentation, can actually hurt learning. The paper suggests that VR might be more prone to this than AR, as AR still grounds you in the real world. Even the virtual teacher themselves can add to cognitive load because you have to process their social cues. However, the interaction itself could also reduce cognitive load in some ways, potentially by offloading some of the mental work. It's a complex interplay. On the upside, immersive environments can increase cognitive activation. This means they can really grab your attention and get your brain working harder to understand things, leading to deeper learning. One of the most important insights is the role of temporal dynamics, meaning how things change over time. When you first try XR, it is all about getting used to the technology. As you become more familiar, you can focus more on the learning and the agent. Crucially, the relationship you build with the virtual agent, that human-agent space, doesn't form overnight. It develops over time through repeated interactions, similar to how human relationships grow according to the social penetration theory. This theory suggests that relationships develop through stages involving increasing levels of self-disclosure. Surprisingly, people might even disclose more to virtual agents earlier than to humans, perhaps because they seem less judgmental. But factors like cybersickness and technical glitches can slow down this relationship development. And interestingly, a highly realistic agent might speed it up. The initial excitement in XR is often due to the novelty effect, but that fades. The hope is that the developing relationship with the agent can keep motivation high long-term. Cybersickness symptoms can also change over time within a session, sometimes increasing and then decreasing. Initially, the novelty and complexity of XR might lead to higher extraneous cognitive load, but with familiarity, this should decrease. So, what is the big picture? Immersive learning with pedagogical agents offers huge potential. You get that amazing feeling of presence and embodiment, deep engagement, increased motivation, and stronger self-efficacy. But there are real risks like cybersickness, cognitive overload, and the uncanny valley effect if the agent is almost real but not quite. The way you interact can mimic real human interactions, driving both task-focused learning and personal connections. This can deepen understanding and even emotional investment. The authors point out that there's still a lot we don't know. Most of the findings for agents in XR are based on studies from less immersive settings or on avatars. We need more studies specifically looking at these agent-centered XR learning environments. They highlight the complex relationships between agent realism, social presence, and how we form relationships with these agents. We need to figure out how these factors balance out to either boost or hinder learning. And we really need to understand the temporal dynamics better. How do these experiences evolve over multiple sessions and over time? Ultimately, to make this type of learning truly effective, we need smart instructional design principles. These will guide how we build these virtual learning experiences to harness the power of immersion and AI agents while minimizing the potential downsides. This framework they've laid out is a fantastic starting point for researchers and developers to build upon. It's a complex, exciting field, and seeing how these virtual worlds can genuinely help us learn is something I am really curious about. What do you think? Have you had experiences with virtual teachers or in immersive games? Let me know in the comments below. If you found this breakdown helpful, please give it a thumbs up, subscribe to Rubin's Mind Lab for more science deep dives, and hit that notification bell so you don't miss our next exploration into the fascinating world of psychology. Thanks for watching, and I'll see you in the next one.